With that, we move to the next presentation. I mean, next one, which is basically we'll go over. Caleb, what is it? The forum?
Yeah, it's just it's kind of just open forum, right?
Yes.
So
David, if you can stay actually on the call in case there are questions for you. There would be any question for the battery, you would be able to answer. I actually would think that we can ask everybody, open up the Zoom, and anyone that like to join and ask question, they can go live. So we can click to gain a speaker access at the bottom of the presentation and go join the call. And you can ask your question live.
We do have several people that did join the call. So anyone that just joined the call, do you have any questions or comments about the previous session?
I go through the comments, questions, and wait for other people if they want to join in and ask questions. Let me.
Yeah, so just this period of time we've got blocked out is for essentially any questions related to any of the topics that we talked about this morning. So that could be around OpenRacket, PowerShell, BBU, anything that you're curious about. Essentially, we're open to answer those questions right now.
I go through the comments in case there is any question that we missed. One question that I see here is that do you still need AC hold-up time requirement in the PSU if a battery shelf is used? David,
yeah,
can you
transition,
take that?
right? For the transition to the BBU, we need some time. So
okay,
that's correct. We still need a PSU have hold-up time.
So what is the industry requirement on hold-up? Like putting the iTech on the side, is there any industry and standard requirement for hold-up time? I heard different values from like 10 to 20 milliseconds.
It's Hamid, that's typically, as you mentioned, is typically a line cycle. That's traditional. That's exactly what we have seen in most of the applications.
I see.
I believe there is an industry standard. I forgot the name. Maybe Ralph knows. It's IP. I forgot the name.
So IPC.
Yeah.
IPC 9592, I think.
No, there's another IPMI or something. Yeah.
This is the ITIC. You mean?
ITIC.
Yeah, but ITIC generally, David, specifies the voltage disturbance or the AC boundary. Not sure it dives in. I mean, yes, you're right. If you're going to meet the 20-second dropout, you would need that, right? Indirectly, yes.
So if we compare to the 12-volt traditional server supplies, which run in a 2N redundancy, they request 12 milliseconds at full load, right? Because they run only at half load, because they are 2. So then you automatically have 20 or 22, 24 milliseconds. And the 48-volt units normally, they all have 20 milliseconds, but they allow a drop of the output voltage down to 40 or 42 volt. So this helped. But here, if we need to keep the voltage constant at 50 volt or 48 volt, this is a challenge, let's say like this.
Okay. One question, Harry, you mentioned about USB-C.
Correct. So yeah, I can read it out loud here, right? We heard that Zoe mentioned and you mentioned the USB-C. Has that been confirmed and is spec being updated? The reason we ask is we are updating the next version of controller and we want to make sure it's taken into account when we build it.
Yeah, the reason for the USB-C is the connector that actually you can plug into the PMC and you will be able to you would be able to debug the board live. This is something that we do for the servers. So we were asked, can we do for this module as well? We put it on the prototype. It's not finalized that we would be able to accommodate all the difficulties, and once it's final, we will add it to the spec. But in terms of the hardware, actually the ASP chip can support that. And it's just a USB-C you have to put on the front, but adding that USB-C on the front can change the, in order to actually make it to work, you actually have changed the, somehow change the handle design to make a room for that USB-C and the cable to plug in. So that brings some challenges. Not to be, it is not to be unsolvable. You can, but it adds some. Then the handle, like the handle spec, also needs to update. So let us actually work on this and as part of that prototype that we put it in to test and see it's working and we like it, and then we add it to the spec. But actually, it's just more for debugging. And if you want to see what it is, look at the OCP debug card. It's already on the OCP website, and then from there you can see actually what it is and has to support. It's a very simple thing.
Got it. Thank you.
Yeah, I see a few folks joined the call. Feel free to ask your question live. Samir, do you have any questions?
Just curious
Bayan, Lam.
why the surge protection has decreased from ORV2. I think ORV2 used to be 2 kV, 4 kV. Now it's 1 and 2. The reason I ask is because now there's no more surge protection in the ORV3 PDU. So that's just a pass-through cable. And with Facebook's architecture, you're connected directly to the high voltage transformer without any surge protection. Versus like a traditional colo, we have the UPS and PDU in line to protect against the surge. And now with this architecture, there's a risk. I'm just curious why it's been reduced.
Yeah, one reason, one architecture change that we thought to do is to compare to V2 is to remove the PDUs. The PDUs, we have some issues with that. It is if some module fails or some unit breaks, someone has to go and replace that. It's a difficult thing to do, and having some such protection inside the power shelf was not very preferred. So we tried to move everything inside the power PSU. That helps. That in case any surge and issue we have, we just replace the PSU. So that is like the concept behind this design. To your second question, that you mentioned the surge protection on the previous design was 2 kV. That's what you mentioned. I need to look at that.
2 kV, 4 kV CMDM.
Yeah, I need to look at that. So let me. That one I don't have an answer for you. Let me look at that and see why did it change. So on V2, is 1 kV stronger than 2 kV? I thought that 1 kV, if you have 1 kV, that's where your varistors start to break, versus 2 kV. So,
So it's
maybe
2
1
kV differential mode and 4 kV COM mode. And now, so the legal requirement is 1 kilovolt and 2 kilovolt. So the V2 was double of the legal requirement, and I think now it's back to the legal.
So actually V3 is more stringent in that case, I would say, yes?
No, it's a standard, so the legal standard actually.
I see. So that's 1 kV. What does it mean by 1 kV or 2 kV? Does it mean the varistor should withstand 1 kV, or if the varistor should, what does that 1 kV term mean?
The first value, the differential mode, is between line and neutral. So this is 1 kV, so 1000 volt. And the second value, the 2 kV, is a COM mode. It's between L and PE or N and PE.
Yeah, but Ralph, I think Hamid's asking is 1 kV, 2 kV better performance than 2 kV, 4 kV? Is the breakdown voltage it's at 1 kV where it shorts, but having it, what's the difference between having 1 kV differential mode versus 2 kV differential mode?
Yes, that's my
Yeah,
question.
two is
It's a
double the
location.
severeness, right?
I'm sorry, Ralph, go ahead.
Yeah, go ahead, Lam. So
I think it's
sorry.
locations of the IT equipment compared to where the power entries at the building. So for the IT equipment, it's far away from the power entry. So it's a 1 kV and 2 kV. So if you are closer to the entry, then a 2 kV and 4 kV. And if outdoor, like a 6 kV. So.
Got it.
Yeah, to answer the question, the voltage level is the testing voltage, honey. So 4 kV is more severe than 2 kV.
Oh, so it has to be the standard voltage.
The amount of energy that in the pulse. So when they define outdoor, the energy level is higher. I mean, they're talking about 4,000 amp or 2,000 amp or 1,000 amp. So
I see. So I mean, are we now feel comfortable with having going with the standard 1 kV or 2 kV, or should we switch to the 2 kV and 4 kV?
I think we should be 4 kV and 2 kV. Level 4 is better because in our, yeah, like Samir said, level 4 is more robust. As we removed the PDU, right? The PDU originally has some surge protection device. So now we should have more, at least the equal level of surge immunity in the PSU.
All right.
But we can double check with Ben. You know,
okay, I wrote it down as an item that we go through. Right. Yeah. Thank you, Samir, for that feedback. I'm looking at the questions. Is that there's a question that says, I mean, BBU or even like the other components of V3 are more of right now in concept stage and like prototyping. When is V3 architecture expected to start entering data centers? Maybe Steve can answer that question.
Yeah, so right now we're just trying to get the specifications ironed out. So hopefully later this year we'll have the specifications pretty well finalized. So, I mean, after that it'll be up to suppliers on how quickly we can get those up and running. So we'll have to, I guess, check in again later next year to give you kind of an update on that.
Thank you.
Sure.
The other question.
I was going to say too, Hamid,
Sure.
I saw one question pop up. There are people asking about how they do join. I know Archana messaged them back. Feel free to join, and there's that join now button in the FN virtual tool, and you guys can join that way as well. So, Howie, if you wanted to join in that way, you can.
Yeah, just scroll a little bit further down below the video screen and it says click to gain speaker access, and there's a big white button that says join now. Press that, and then Kaylee and I will let you in.
Yep, hit that big white button. So one question that popped up, let's see. One fan supports BBU cooling is the question.
Yes, one fan. Yeah. It's gonna be most likely a 60 millimeter fan.
Okay.
I just let Osama in. Osama, you have to unmute if you want to ask a question.
Yes, got it. Thank you.
Mm-hmm.
Go ahead.
Do you have a question? Sorry, wasn't sure if you joined to ask a question.
No, not at the moment. I'm just listening. Thank you.
I see Harry or Howie just joined. I saw you had a question there. If you want to go ahead, unmute yourself and fire away.
Yes, got it. Thank you.
Okay, so I had a question about.
If you are joining live, you have to unmute the presentation, the other one.
Yeah, you
if
have
you're
to
joining
mute the
live
other one.
with Zoom, go ahead and mute your F and virtual window so that we don't hear the echo. Thanks.
All right, Howie, go ahead.
All right, so I have a question about the.
Howie, it might be on your screen. You know, the F and virtual video screen that you're watching through the live stream, just hit the mute button on that. It's
Okay.
right under it. So scroll down, there's a play button and a volume button. Just hit it, hit that.
All right, I'm lost here, so.
Okay. Well,
Yeah,
we
you
don't need the
have to hover
feedback
over.
anymore.
No.
Yeah, try it. Go ahead, Howie, give it a shot.
Can you all see me?
Mm-hmm.
Okay.
Yep, we can see and hear you.
All right, good. So I have a question about the cell selection. So in the specifications, we're showing 1.5 amp, and David, you referred to 1.6.
Yeah.
And I know there's been conversations of cell capacities anywhere up to 2.5 amp hours. Has there been any focus in on a particular one?
Yes, we already identified the cell candidates for our V3 application. We have at least 2 or 3 suppliers for the cells, which are all capable to support our capacity requirements. So, yeah, I know you work with Murata closely, right? Yeah, Murata is one of the candidates.
Okay.
Yeah.
Yeah, because I know that there were 2 different capacities that we had
Right.
discussions around.
I've seen 2.5 ampere, yes, and more than 2 ampere, yes.
Isn't 1.5 amp hours very low?
Our V2 is using like a 1.6 ampere cells, but V3 we're gonna use both of them, 1.6 and higher capacity. Yeah, depend on different vendors. Even 1.6 ampere hour still meet our requirements.
Okay, thank you.
And one question that I saw, that's for Tiffany. Tiffany, the question is that what is the green board in the PMC PMI module for? Tiffany, can you hear me?
Yeah, so there's a green board that's the PCB as part of the PMC module, and then there's an adapter board that you can use to do the jump from the PMC to the motherboard. So I'm not sure which one is being referred to.
The PMC itself. The green board.
Oh, the green board is the PCB.
Is a PCB. I think it might be confusing because it's empty PCB. It is the design, so the different people can have different electronics.
Yeah, I think you're right. That was just they probably looked at the model or the illustration, right, and saw the green board without anything on it.
The other question for you, Tiffany, is that why is PMX not enclosed?
Why is say that again?
Why is the PMC PMI not enclosed? Doesn't have full enclosure?
We decided to make it more like a card edge connector, similar to like the NIC.
Okay. it doesn't have even the fan, so it actually make it easier. Is that correct?
Yeah, we tried to make it as simple as possible.
Mm-hmm. Got it. I'm looking for more questions. Another question Samir asked, is the BBU fan always on?
Yes. Even in standby mode, as I mentioned, the fan has to be running to keep the cell temperature low enough. Because in the data center, we have hot aisle and the cold aisle. If the fan is not spinning, the hot aisle temperature, airflow may backflow into the BBU and heat up the cells and causing the accelerated aging of the cells.
I see.
Yeah.
Okay.
I have a
you.
V3 PDU question for Tiffany. From the model, I see that you have like that cable jack, the jacket with that encloses the 5 wires, and then it splits out red and it goes inside the little housing. At that point, there's only like one layer of insulation on that AC wires because you don't have the cable jacket anymore. Is that a safety concern?
You're talking about the AC input connector, right?
Correct, yeah.
Oh, that's just the CAD picture.
Okay. The jacket would go all the way to inside.
Yeah, I think the jacket would go all the way.
Okay.
Another question from Andre. When we can see updated OpenRack V3 frame 3D model on Open Compute website?
I can take that one, Hamid. So we were hoping to have another update of the CAD that we've previously published by the end of this year. So we don't plan on pushing out another, like a full size, but there'll be another kind of cross section from the middle of the rack to help people that are building IT gear kind of design around OpenRack V3, so I'll be ready for it. So that's the plan right now. We'll have some updated CAD for the community.
Okay. One question from Dustin. Are the support beams still using the same fastener mounting requirements?
The support beams.
Yeah, I'm not sure if he's talking about the the rails on the side or
the cross beam. There could be a few different things. Maybe can you add some more context to that question?
Yeah, maybe we can get him to add some more information about what he's looking for.
Yeah, Dustin, if you are there, please add more details there. The other question from Robert, does V3 support both 12 volt and 48 volt bus bars?
So I can talk to that one as well. So right now we are not working on developing a 12 volt version of the bus bar for OpenRack V3 specifically, but the volume for the bus bars, whether it's 12 volt or 48 or both, kind of defined in the OpenRack specification. Both of them will be compliant. So there's no reason that somebody couldn't go and put a 12 volt bus bar onto an OpenRack V3. There's nothing preventing that. It's just we're, at least right now, there's nobody in the community that I'm aware of that's actually going through and productizing that right now. So that'd be a good question for any of the suppliers that are making bus bars if they're interested in supporting that or not.
All right. The other question I see, I think it's more for you, Archana. It says that it seems like they had difficulty joining during the V3 monitoring and control presentation. They couldn't reconnect. Maybe I think, can you explain when should be able to do the presentation again? And upload it somewhere and they would be able to see it.
So I'm sorry, they had trouble during the session, or is this after after the session aired, and they're just wondering when it'll be available on
It
demand.
seems like it was during the session that they couldn't see.
They couldn't view it. Okay.
Yeah.
So next week, we're working on having all of the videos up, and then after that, not only the slides are available for download, but the videos will be up. So check back next week, same platform, and you should be able to see all the videos on demand.
Will that material be only available to who are registered, or it's public?
No, it'll only be available to those that are registered.
All right, thank you.
Mm-hmm.
I see Gabby join. Gabby, do you want to unmute and ask your question? Am I pronouncing your name correctly? All right, go ahead, ask your question.
Well, sorry, I didn't want to interrupt Archana.
I'm done, so you can go ahead and interrupt me.
It's it.
Yeah, you have to mute yourself on the. You have to mute yourself on the Fantech website. That's why you keep thinking that Archana is talking.
Yeah, mute mute the stream, and then you can talk on the Zoom.
I just got it, and I did mute the stream. And I wanted to mention the Archana already responded to my previous question on the forum here on the board. There's a delay in time, and I think that's what confuses things for everybody, the delay in time. So no problems whatsoever. I'll just back off right now.
Okay. I see one last question here. Are there any plans to design power shelf and battery shelf compatible with immersion cooling?
I can talk to that, Hamid. So, yeah, so right now there's no one in the community that is working to convert the existing power shelf and BBU designs to immersion. Not that it necessarily couldn't be done, but there's lots of additional requirements that have to go through for material compatibility, which I'm not aware of anybody doing that. If there's anybody on the call, any of the power shelf suppliers that happen to already be doing that, feel free to speak up. But I'm not aware of any initiative that's actively working on that right this second.
We've taken an initial look at it, Steve, and we've basically figured out that unless the BBU module is above 5 kilowatts, that we don't know if we'd see much of a benefit. Plus the other piece, we would have to pot the entire assembly, which adds some cost and creates some risk for the battery piece of it. So, we're interested in taking a look at it maybe at a later date, but the way that it's configured now with the 3 kilowatt blocks probably doesn't make a lot of sense. Because you have to do a lot of thermal analysis as well, because essentially where you're shutting off the battery is when it hits its T max. And that's what we're carefully monitoring. So if we had to pot the whole core battery pack, it creates some other challenges. So not quite there yet.
Yep, sure. That makes sense, right? There's just not a lot of power density in that compared to the capabilities of immersion. So
yeah.
But yeah, thanks for filling us in.
But the PSU has been submerged without any problem. I mean, we supply some power supply to submerge, and they put the whole PSU and power shell inside liquid.
So what changes has to be done in order like the OpenRAC V3 PSU and power shelf to be able to submerge?
Actually, all the components can be submerged. The only thing that is questions is they would like us to defeat the fan so the fan doesn't run, and they use their fan. They use their fan to move they use their own way to move the liquid through the power shell instead of the power supply fan itself.
And the relay sometimes need to be changed to a sealed version.
Yeah.
Because if the liquid goes into the relay, then the contacts don't like it.
I see.
Yeah, and in the case of the cells, there is a venting mechanism. Should you start to get into a problematic situation, and you would have to essentially carefully make a venting process built into the product that wouldn't get clogged with the oil.
I would say assume if they want to the fan on the PSU to run, probably that fan has to change as well, because that's fan basically designed for air.
Actually, that fan can run in the liquid. We had a power supply in our lab in Taipei that been running for a few years in liquid with fan.
Oh, interesting. The same fan can run on liquid?
Yes. Yes.
Oh, wouldn't it be getting overloaded or too
No,
much
it
pressure?
just run slow.
Oh, on slow mode. Okay. Caleb, I don't see any question there on live.
Yeah, I think we're good. It looks like that has been all the questions. That's really appreciate everybody jumping in for this live session. That was good. I think we should make more time for more of these live sessions. Cool. I think we're gonna take lunch break.
Yeah.
If I'm right.
Yep. Meet back at 1 o'clock.
Sounds good.
Thanks,
Same
everyone.
Zoom link.
Okay.
Thanks,
All right. See
Thank
everybody
you,
in an hour.
everybody.
Thank you. Bye.
Right.